Let's continue with problem number 3, 4, and 5. In these three problems, what we have is find the values of x, if any, where there are holes in the graph of the function. And that's exactly what we do in step number 1. Remember, after we have a fraction, a rational function, a function which is a fraction, we try to, the first step is factor and cancel. So, and in case you get rid of common factors, it says here, in this specific case, there was no holes because we didn't have any common factors. But in case you do have a factor, then you cancel it out, and then you have a hole. So in these three problems, we're going to see that. See, for example, problem number 3. I'm going to solve number 3 and number 4. Okay. Number 3. This is f of x equals x plus 2 squared over x squared plus 5x plus 6. So let's start by factoring the top and the bottom of the problem. Let me see if we can see this better, like this. Okay, I hope you guys are able to see this. Okay, so we use a different color, maybe this one. Okay, so we're going to factor the top and the bottom. The top part is actually given to us factor. We're just going to write it as we're going to develop this exponent x plus 2 times x plus 2 to see all the factors completely developed. In the denominator, we're looking for 2 factors of 6 that add 5. 2 factors of 6 that add 5. So those factors are going to be in this form: x times x squared plus 2 plus 3. Now look for common factors. We can see very clearly there that x plus 2 is on top and the bottom. So we're going to get rid of those 2 common factors. Once you do this, right away you have to add the condition that x cannot be negative 2, because that in that value the denominator becomes 0, and then we have something that is not valid, right? So it's undefined. So what we have, we're going to work with the problem now is x plus 2 over x plus 3 with the condition that x cannot be negative 2. So at this value, exactly, we have a hole. The hole is a point negative 2. Then in order to find the order coordinate, the y, we're going to plug it in this function, in the function that is already reduced. So we're going to have to find f of negative 2 using this function. Negative 2 plus 2 over negative 2 plus 3. So this is 0 over 1, which is 0. So negative 2, 0 is the hole in this function. So when we graph it, we have to be very careful of drawing that hole. That's the answer for number 3. For number, I said I'm going to solve also number 4. This looks a little bit different, and number 5 is similar to number 4. So number 4 is f of x equals to 9x times 2x minus 1 squared over 2x minus 1 x plus 6 x minus 9. So I'm going to rewrite this 9x 2x minus 1, something similar to what we did in the first one, 2x in the previous one, 2x minus 1 again over 2x minus 1 times x plus 6 times x minus 9. Common factors, the only common factors we have is 2x minus 1 and 2x minus 1. 2x minus 1 cannot be 0. So what x do we need to exclude from here? In order to see clearly what is the value of the x that we don't want, is what we have to do here is actually solve that equation, right? Equals to 0. So this equation, to exclude that specific value. So I'm going to solve that equation over here. 2x minus 1 is going to be equal to 0 when 2x equals 1. And if I divide by 2, x equals 1/2 is a value that we don't want. So x cannot be 1/2, because at 1/2 we're going to have a whole. In other words, 1/2 is not an element of the domain. So what is the whole then? The whole is going to have coordinates 1/2. And in order to find the value for y, we use the function that is already reduced, which is 9x times 2x minus 1 over x plus 6, x minus 9. But if you notice it here, if you plug in 1/2 on the top part, 2 times 1/2 is 1, minus 1 is 0. The top part is going to be 0. The bottom part is not going to be 0, so it is going to be defined, because you add 1/2 here, it will be 16 1/2 times 1/2 minus 9. So the value on the top is 0. So this is 0, right? So f of x is going to be 0 over that value that is no 0. So 6.5 times this value, 1/2 minus 9, will be negative 8.5. So when you multiply this, you don't get 0. So the important thing here, this is 0. So the whole is going to be at 1/2, 0.